Okay, I'm going to show you how to calculate the empirical formula when these are the percent composition. All right, so what I'm going to do first is assume that since percents are based on 100, we're going to assume I have 100 grams of this substance. So in fact, I have 50 grams of carbon, I have 5.6 grams of hydrogen, and I have 44.4 grams of oxygen. Okay. Then what I need to remember is there is a formula which says moles equals mass over gram formula mass. You don't remember, it's on table T, don't have to memorize it. And in formulas, so for example, this formula right here, these subscripts represent moles, mole ratios, when we're considering a mole of this compound. So we need to find moles so that we can write a formula. So I have mass. So how do I find gram formula mass? Well, I just take the gram formula mass from the periodic table for the element. So let's start here writing carbon, we'll write hydrogen, and we'll write oxygen. Okay, so carbon is going to be 50 grams divided by 12 grams per mole. Hydrogen is going to be 5.6 grams divided by 1 gram per mole. And oxygen is going to be 44.4 grams divided by 16 grams per mole. Okay, so do you see where I got here? This is the molar mass of carbon, the molar mass of hydrogen, the molar mass of oxygen, also called the gram formula mass. Why do I need it? I need to take mass divided by gram formula mass to get moles. I need moles to write my formula, okay? So I'm going to do the math for each one of these. I take 50 divided by 12. And I already did this math, so that is going to give me 4.1667. Hydrogen, that's easy. 5.6 divided by 1 is 5.6. And then oxygen, 44.4 divided by 16 gives me 2.775. So these tell me mole ratios, which allows me to write the formula. Okay, so what would the formula look like if I wrote it? It would look like this. C, 4.1667. H, 5.6. O, 2.775. Have you ever seen a formula like that? No way, you have not. So that's unacceptable. So I have to do something about it. So what am I going to do? Well, I need these to be whole numbers. Okay, so what I'm going to do is look for the smallest one, because if I know I take the smallest one and I divide it by itself, it gives me 1, and then every other number will be 1 or bigger than 1. I don't want to get smaller than 1, that would be worse. Okay, so the smallest that I have here is 2.775. Okay, so I'm going to get a new subscript. So 2.775 divided by 2.775 is 1. But since I divided this one by 2.775, guess what I have to do with all of these? Otherwise, I'm completely changing the ratio. So I have to do 5.6 divided by 2.775, and that's 2. And then I have to do 4.1667 divided by 2.775, and that is 1.5. Okay, well, I got a lot closer. That looks a lot better, but here is still a problem. I can't have that decimal, so I have to get rid of it. Now, you might think at first I should divide, but if I start dividing, so if I divide this by 1.5, and then I divide 2 divided by 1.5. Let's just see what we get. 2 divided by 1.5. Oh no, more long decimals. And if I do 1 divided by 1.5. Okay, problematic. I get terrible decimals. So I don't want to divide. This time I want to multiply. And the numbers to try multiplying by are 2, 3, 4, 5. Worst case scenario, maybe you have to go higher than that, but I haven't really seen it. So try 2 first. So what does that mean? I'm going to take 1.5 times 2. But if I do that, I need to do this one times 2 and this one times 2. So let's see. 1.5 times 2 is 3. 2 times 2 is 4. And 1 times 2 is 2. Huh. We got there. This is it. This is the empirical formula. That's it. So these percent compositions yields this empirical formula, okay? So you have to really do it step by step. You have to find moles because you need moles to write a formula. You can't write a formula with decimals, so you need a whole number. Start with the smallest, get a 1. You can't leave decimals, so start multiplying until you get there. And that is how you take percent composition and turn it into an empirical formula.